how exactly did we get from swinging through a dense jungle canopy to building miles of glowing servers? To understand that journey, we have to look back. We didn't actually evolve from the modern monkeys you see today. Instead, we share a common ancestor with chimpanzees and bonobos. Around 4 to 6 million years ago, early hominids started walking on two legs. Suddenly, our hands were free to grab, carry, and use tools. Freeing our hands allowed us to manipulate the physical environment around us. But to fully master that environment, we needed a massive hardware upgrade inside our heads. As our ancestors spread into new environments, our brain volume expanded rapidly. We developed a highly complex prefrontal cortex, the specific area of the brain responsible for deep social interaction and complex decision-making. But biology enforces a strict physical limit. No matter how dense our internal neural network became, all of our storage and processing capabilities were trapped inside a rigid bone shell. We hit a biological ceiling. To go further, human intelligence had to find a way to break out of the body entirely. The escape began roughly 70,000 years ago during the cognitive revolution. We developed spoken language, which allowed us to share abstract ideas, things that didn't physically exist in front of us, like myths, laws, and future plans. Then we started putting those ideas onto physical surfaces, creating our very first external hard drives. By around 3400 BCE, the invention of writing allowed us to record exact data and permanently bypass the limits of biological memory. We were no longer relying on fragile internal neurons to remember everything. A piece of information could now survive indefinitely as an indestructible external object. For millennia, tools like the hammer or the steam engine mostly extended our physical reach. They replaced human muscle power with mechanics. In the mid-20th century, scientists like Alan Turing asked a different question. Could we build a machine to replicate human logic? By the 1940s, researchers had conceptualized the universal Turing machine. We now had a system capable of active reasoning, wired to process mathematical operations. Humanity was now building external systems capable of active logic, tools that could turn raw data into executable decisions. Early artificial intelligence relied on strict if-then commands to mimic human thought. However, these rigid programmed rules were fragile and completely failed to handle the unpredictable messiness of the real world. So computer scientists pivoted to machine learning. Instead of programming machines with thousands of hard-coded rules, they fed them massive datasets and allowed the computers to discover patterns on their own. This diagram outlines the architecture of a modern neural network. It directly models the layered structure of the biological brain, mapping organic neurons directly to digital nodes. We found that to build a truly capable artificial mind, writing better code wasn't enough. We had to copy the exact blueprint of biology. Comparing evolutionary mechanisms, the left side shows biological adaptation. Relying on genetic mutation took millions of years to yield significant cognitive growth. On the right side, technological evolution, driven by algorithmic fine-tuning and data training, achieves similar cognitive leaps in mere months. Transitioning our processing from carbon-based neurons to silicon servers bypassed the slow constraints of biological time. Exporting our thoughts, memories, and logic into the physical world has always been our species' most successful evolutionary strategy. Artificial intelligence follows a lineage that began with hand axes and cave paintings, each step moving more of our internal complexity into the physical world. We spent millions of years evolving a brain capable of understanding the universe. Now, we are using that exact brain to build a digital descendant, one that processes information faster